Okay, in this video we're going to look at the differentiation of trigonomic functions. So what we're going to do before we do anything, we're just going to go to autograph. So when you open an autograph, this is the window you get. Let's first of all get rid of this window at the bottom. Okay, and then let's set the axis. So to set the axis you need to use this one here. Okay, and we're going to put 0 in here. And to do trigonometry, differentiation of trigonometry, you have to use radians. Put 0 in here, and we want this to be 2 pi. So it's 2, and then write pi, and then the pi sign comes out. You can just about see the pi sign there. Okay, let's change this here to the numbers. We'll have these every pi by 4. So it's pi divided by 4, and we'll have the pips at pi divided by 4. So pi divided by 4. And we'll have the y-axis from minus 1.5 to 1.5. The numbers are every 0.5, and the pips are every 0.5. And then we'll press OK, and then we get our axis. Okay, so first of all we'll put in the graph of y is equal to sine x. And we get the graph y is equal to sine x. So we'll click on that and we will label it. It's converted to static text. We don't need any dynamic text for this. And we'll press OK. And we'll just label the graph somewhere here. Y is equal to sine x. So remember, what we're interested in is finding the gradient, the formula for the gradient for finding this. So what happens when we differentiate sine x? And we're just going to look at this graphically. So on autographs, you can, given the graph, you can click this one here. It will give you the gradient function. So if you click on the graph sine x and click on the graph here, okay, and in here I just want you to put in first derivative, okay, and then press OK. Okay, and we'll just click out there, and we can see now what does that graph look like. So what does this graph remind you of? Now if you stop the video now and try to think carefully what that graph reminds you of. Okay, this is actually the graph of cos x between 0 and 2 pi. So, by the way, you must make sure autograph is in radian measure to do this. So click on this, okay, and create a text box and convert to static text. Okay, otherwise it might crash the program. So we want first derivative. Let's just get rid of this bit. In fact, get rid of it. First derivative is equal to y, and because we're going to use derivative with dash, is equal to cos x. We'll press OK. Okay, and then we'll move this over here somewhere. Okay, and we'll just move this here like that. Okay, so if this is y is equal to sine x, when we differentiate sine x, we get the graph of cos x. So that's quite simple, isn't it? So if y is equal to sine x, dy by dx is equal to cos x. But what happens if we differentiate cos x? And again, we're going to look at this graphically. So we'll just click on cos x graph, and again we'll hit this button here. Again, the gradient function. Okay, and we'll put in here second derivative. Okay, and we'll press OK, and we'll click again, and I'm just going to change the colour of that to something a bit more nicer. I'll change it to green. Okay, so what does this graph look like? Well, this is a reflection of the graph of y is equal to sine x. So if we differentiate cos x, we get the graph of minus sine x. That makes life very easy as well. I'll just label that one as well. So just click on it, get the text box converted to static text, and we'll just get rid of all this. Okay, and we'll put that the second derivative is y double dashed is equal to minus sine press OK. Okay, and we'll just move that label somewhere, and we can label the graph. I'll put an arrow to the graph. Okay, so go back to our sketch. So x must be in radians to do this. Okay, so just go back to our graph. This is y is equal to sin x. Okay, when if we differentiate sin x, we get cosx, and if we differentiate cosx, we get minus sin x. Just looking at it graphically, it can be proved algebraically. Okay, so if y is equal to sin x, dy by dx is equal to cosx. If y is equal to cosx, dy by dx is equal to minus sin x. That's the conclusion from this, and therefore d dx of sin x is equal to cosx, and d dx of cosx is equal to minus sin x. This is just another way of writing that this differential this is equal to this, and the differential this is equal to this. Okay, and remember what we are doing when we differentiate, we are finding the gradient function. So we're finding a formula for the gradient.